Housing is one of the major economic, environmental and social challenges facing every person in the world. As Perth's suburbs continue to grow, the demand for natural resources for building new houses grows too. The energy needed to heat and cool those houses continues to climb. Water consumption soars, and many house designs don't accommodate the changing needs of their occupants.
But it doesn't have to be that way. By using smart design, we can reduce the amount of resources required for building and running our homes. We can future-proof them to make sure that they suit the needs of the changing circumstances of our lives. And we can make them healthy, comfortable places to live while minimising their impact on the environment. In this way, the houses we build will be much more sustainable.
All levels of government in Australia are focused on reducing energy consumption in the residential sector. In 2001, the city of Subiaco embarked on a project to demonstrate that environmentally sensitive and socially sustainable design can be attractive, affordable and accessible to home builders and renovators. The result was a public education project called the Subiaco Sustainable Demonstration Home. The house was opened to the public by the Premier of Western Australia in March 2004.
The original brief to the designers required the house to be functional but stylish. It had to fit in with the neighbours and it had to be affordable.
I thought if you try and imagine the house with an overcoat on. Now the overcoat you can keep changing, whether it's red, yellow, lapels or otherwise. The same way you can change styles. But what's really fundamental is that you get the principles right. And they are that you start acknowledging that you need thermal mass in a climate like Perth. You need lots of north-facing glass. You need cross-ventilation in order to be able to, in summer, cool down all the thermal mass that you have inside. And you also need insulation, particularly in the roof.
The home had to be physically and financially accessible to a variety of potential occupants, from families with kids to working couples, empty nesters and people of all abilities. It had to require minimal energy for space heating and cooling, incorporate easy-to-use water-saving and reuse systems, and be low allergen. It was the first sustainable demonstration home in Australia to combine all these elements.
So let's take a closer look at how the design works. You know, the first thing you notice when you walk in here is how good it feels. Outside, it's a warm summer's day, but in here, it's remarkably cool and it smells fresh. But there's no air conditioning. The interior temperature is maintained between 18 to 28 degrees all year round. And basically, that's thanks to the simple principles of solar passive design. Now, these principles include careful orientation of the house on the block, plus well-designed and situated windows, excellent ventilation, insulation, shading, plus the strategic placement of what they call thermal mass.
The house has been oriented on the block to make the most of the sun's different seasonal paths. It faces south, but the largest windows are on the north. In summer, the sun's hot, high-angled rays are kept out by louvers, overhangs, solar louvers and deciduous trees and vines. In winter, low-angled sunlight shines deep into the house and directly onto the thermal mass. The central stairwell is in the core of the house. It acts as the central heater and air conditioner, using the same principle that attracts lizards to warm rocks in the natural environment.
Thermal mass is a critical part of the building. In this house in particular, what we have is we've used recycled rubble to create the thermal mass, which we've isolated by putting it in the middle of the house. What that does is we have the sun come in, that mass absorbs the heat through winter, and then it has to get up to a certain temperature. So at night, when the air temperature goes down, the heat comes out of that mass and then heats up the room. But an important part that people don't realise is that in summer, that mass is used to offset temperature gain. So the excess heat that comes into the building actually gets absorbed from the highest point of that mass downwards and offsets temperature gains. So it's important to have the right amount of mass in the right position in the home, isolated as much as possible from the outside, and the correct relationship to the amount of glass and the volume of air in the house.
Given the huge amount of energy that goes into manufacturing bricks, it truly is a waste of natural resources to send demolition rubble to landfill. So, the rubble from the previous building on this site has been recycled to create this winter warming, summer cooling thermal mass. Very clever.
Removing excess heat from the thermal mass in summer is done by another natural process, ventilation. The house generates its own airflow without a sea breeze or fans. The large northern windows and smaller southern windows create positive, negative air pressure. This is another idea borrowed from nature, where burrowing ground animals do the same thing to keep their homes cool, dry and fresh. The placement of the windows in this house ensures that cool evening air flows along the thermal mass, drawing the heat out. A bit like blowing on a hot potato.
The other means of controlling temperature in the house is insulation, but not just in the ceiling. There's also insulation in the roof and in the eastern and western walls. This makes sense because a lot of heat from morning and afternoon summer sun penetrates through these walls. With so much insulation, the overall effect is like a picnic cooler, but on a house-sized scale.
A monitoring system installed at the home recorded its thermal performance. The black line represents the outside temperature, and the coloured lines are the interior temperatures from the ground floor to the upper level. The home has a 5-star rating using the Sustainable Energy Development Office's first-rate system. It was also rated the most energy-efficient home in Australia from 50 designs assessed during the testing phase of the CSIRO's Accurate software. As you would expect, the house uses solar power for its hot water. But that's not all. It also uses the sun to generate electricity. Perth has about 300 cloudless days a year on average, so it makes sense to use this free energy source. This electricity can be used by the house, and any excess can be sold to the state power grid.
You know, since the late 1970s, the average rainfall in Perth and the southwest has been steadily decreasing. Every drop of water we have is precious, and that's why this home has been designed to use up to 1/3 less water than a conventional house.
Restricted flow, efficient taps and shower heads minimise water and energy wastage. There's a rainwater tank outside, and the home's grey water is reused in the garden.
All these plants have been specially selected for their low water requirements and low allergen properties. Wastewater from the home is treated and is used to water the plants in the garden. The raised garden beds are easily accessed without too much bending, and veggies can be harvested from a wheelchair. It's amazing, but there's more to be allergic to inside most homes than outside. Research has shown that indoor pollutants may be between 2 and 5 times and occasionally 100 times higher than outside. Things like chemicals released from anti-termite treatments, paints, sealants and adhesives, combustion gases from heaters, mould and mildew found in wet areas, fibres from loose insulation and carpet, and of course dust from all those high, flat, hard-to-reach surfaces. That's all kept to a minimum in this home. Through careful design, it provides a low allergenic environment which ensures a healthier living space.
Ceramic floor tiles and bamboo flooring instead of carpet mean no loose fibres and no place for dust mites to live. And there's no heating system emitting potentially toxic combustion gases. The home uses a fine stainless steel mesh as a barrier to deter termites and allergen-free ceiling insulation, which will not produce fibres. The built-in cupboards reach all the way to the ceiling, eliminating dust traps. Both the bathroom windows face north, where sunlight minimises the growth of mould and mildew. To reduce the amount of toxins, the interior paints, adhesives and sealants have low emissions of volatile organic compounds. For a house to suit its occupants in years to come, the design needs to be accessible for occupants regardless of their age or ability. This is the first demonstration house in Western Australia to show how design can be easily adapted to be accessible for most people. The entire ground floor and garden are level. The floors are made of non-slip materials. Extra wide doors allow easy access. All the light switches and power points are at appropriate heights. The taps, door and cupboard handles are easy to use. And the stairway is straight, so installing a chairlift would be simple and cost-effective.
You're probably wondering about cost. Smart design costs no more to build than poor design. The sun does the heating, the house is designed to capture and channel breezes for cooling, and all the low allergen and accessibility features are a matter of smart design, not necessarily extra cost. You know, in the 2 years it's been open to the public, the home's received almost 20,000 visitors, including some distinguished guests from overseas.
The Prince of Wales paid a visit in 2005 to see what the CSIRO called Australia's most energy-efficient house. Many councils, educational institutions and industry groups have visited, and the housing industry regularly use the home as the ideal venue for its Green Smart training seminars. The home's website received more than 400,000 hits. Answering the many questions that were asked during 2 years of public display required an enthusiastic team of specially trained volunteers and staff. Their participation was an important step in engaging the wider community in this project. After 2 years as an educational resource, the home was finally put on the market and sold to private buyers.
Oh, I really liked the house generally, you know. I thought it was a pretty good house, and, you know, it's fuel efficient, you know, it's nice temperature, nice setup, so, you know, I like it. Right.
The Subiaco Sustainable Demonstration Home is a remarkable example of how modern homes can be designed and built to really reduce their energy costs, minimise their impact on the environment, and create a healthy place for the people who live there.
The success of the project far outweighed expectations. The Subiaco Sustainable Demonstration Home has won many state and national awards for its innovative solutions to the sustainability issues facing homeowners. The city of Subiaco is proud to take a leading role in promoting sustainability and educating the community about just how easily we can make our homes work for us and the environment.